I'm going to be very quick. I've realized I have less time than I was planning for. We're going to present BoB, and it's basically going to use a TEE data clean room for sandbox state diff searching. Very simple, actually. You have two users. One is the block builder, one is the searcher, and they are collaborating in a clean data room, which is also sandboxed. So the searcher is going to provide the searcher logic, which is then going to look at the state diff, and depending on the state diff, they might send transactions back to the block builder. And these are bottom of block transactions, so they append to the bottom of the block. What's a data clean room, and why do we need it? We want to have confidentiality for the block builder state diffs. There's that's the state diff of the next block. So you basically want to have that secure and confidential. Nobody wants to see should see this. And at the same time, you want to keep the searcher logic proprietary and confidential, because they sort of have their alpha here and they don't want to have this getting leaked. How do we do it? Of course, with a TDX for confidentiality. We have a base minimal Yocto image, which includes a small kernel, busybox, some init system, and that's basically a deterministic build. So you need this because you have a third-party trust requirement. Anyone wants to verify this via an attestation. And then we are going to add some containerization, which is in this moment Podman, and the dependencies for sandboxing. Same here, why do we need an additional sandbox? Because the searcher logic is going to be arbitrary, and this can basically escape and try to leak the state diffs before they're committed to the block. So we're going to use Podman containerization for that. We're restricting the access and view of the OS, like we do user and net namespacing and some others as well. And these are the main requirements for the rest of the isolation mechanisms. And then on top, we're doing egress net filtering to stop the searcher from trying to leak the state diff. And additionally, because the searcher wants to debug stuff, they have a delayed log output and also delayed maintenance access if something's really going off and wrong. So yeah, these are the steps. So basically, we start with provisioning. The searcher provides the searcher logic within the sandbox, within the data clean room. For this, we have the steps are, first of all, attest and verify the data clean room instance with that attestation token. Then we provide the SSH public key. That's the searcher who provides that via secure channel. And then once they have SSH access, they're just going to apply their logic and dependencies. And then we go in lockdown mode, and then we open production mode, which is then basically streaming state drift and sending BoB transactions back. Production mode, what happens? SSH access is disabled. The searcher logic net filter is enabled, so the searcher searcher logic can't exit anymore, except to the block builder. And then as the next step, the block builder tests the data clean room, and only then will send the state diff via, again, a secure channel. We can also trigger maintenance, which means we're going to block everything again, keep the state diff streaming blocked, and then the searcher can access via SSH again and do some servicing of the logic. And why can we do state diff? Very important. Because the fact is the confidentiality of the state diff is very short-lived. Like if you see a couple of blocks, after that, any kind of transaction that had value before that is most likely not valuable anymore. So that's why we can give access again. Of course, only within a delay, like say 5 or 10 minutes or whatever you want, we can give maintenance mode. What are the takeaways? don't roll your own sandbox. We tried this. We first did just unprivileged user, and then try to put, I don't know, net namespacing on top of that. And it got so complex and so difficult to review and audit that we just said, okay, no, we're just going to use Podman or whatever other containerization method there is. And then we used Podman and realized, oh, these are like user-based containerization methods, and they really don't care about egress net filtering, which again was like really time-consuming and took some time to get right. Steps ahead. I'm going to skip this because I'm out of time. And thank you. If you're interested, onboarding probably starts slowly after DEF CON. You can contact A Star in Mind for details. Thanks.
So there's multiple things that you should consider as a searcher when you're trying to search from the TDX. And I wanted to quickly cover that. I also wanted to have a quick demo SSHing into our machine and showing how things work, but it looks like we don't have time for that. So unfortunately, and also, so I wanted to show how everything works, but we wouldn't have time for that. So unfortunately, and also Google Wi-Fi blocks port 22 for some reason, so I can't connect into this virtual machine. Unfortunately, yeah. So one thing you should consider is the specifics of being in the TEE. Is that the actual build, the image of the OS is memo. And so you should bring your own stuff with yourself. And even the most basic stuff. So for example, if you would like to use Tmax or any other like minimal tooling with you, like EdgeTop or BTop, you should bring the static build with yourself. That's one thing. If you want to bring something more complex, you would need to bring the Podman container with yourself, and that's also an issue because you cannot build Podman containers statically in the TDX for some reason because of the FS issues. That's TDX specific, and so you should build containers locally. Images. Podman images locally, and then transfer it through SSH or like SCP to the searcher machine. And that takes, for example, our searcher image was like 4 gigabytes, and transferring it through Dropbear takes like an hour, because I know for some reason it's throttling for like 3 megabytes per second. And you should consider that. So another issue is if you're working in a team, is that OS only supports one SSH connection for one key, so you wouldn't be able to use some sort of collaboration in this sense, like you normally do with your normal server infrastructure. Another thing is that was mentioned before is maintenance modes. So you wouldn't have access to your machine all the time because of the privacy issues. In our case, we are interacting with the builder, we're receiving state diffs from it, and so builder wants the state diffs to be useless, like if we have access to them, right? So outside of the TDX. And so we have this timeout of going to maintenance mode, and you should consider if you're running a bot that could lose money if something goes wrong. And then wanted to cover some specifics about Podman. So Podman containers are running in the rootless mode, as was mentioned before. And that could be quite challenging to move if you're moving from a Docker with lots of microservices, especially considering that the networking is different there as well. And I also personally bumped into some bugs in the Podman networking, and like that's really hard to debug when you are inside TDX. So you should consider that. And then, yeah, and okay, as already mentioned, image building doesn't work locally. When to cover the future, how the searching in TDX could be expanded and have broader impact on the ecosystem, especially considering the current state on the main block building on the mainnet inside PBS. So currently, the current problem with searching is that all bundles generated inside TDX are burdening the builder. So we send these as normal bundles, which means that builders should simulate them and as well, and that adds a huge overhead if you want to decentralize the process and onboard many searchers. So if you have many searchers will generate lots of spam. They wouldn't be able to control it because it's inside TDX, and like builder would be just overwhelmed by this amount of bundles. And so what we can do about this, that is builders could outsource some of sequencing and execution logic to the searcher. So searcher would be shipping already executed content to the builder, for example. So once we solve this problem, we could then decentralize the process. We could onboard more searchers, and thus these searchers would have more control over the sequencing and MEV searching. Builders wouldn't have as much control over the block space as well. And that would be more efficient as well because the compute will be distributed over the large network of nodes rather than being throttled by the centralized entity that would have to sequence all the transactions and like execute them in the correct order. Then what we could do then is to add the proposer into this chain, right, to achieve end-to-end privacy of the order flow. So if you have currently, you trust the builder to keep your order flow private. Builder trusts searchers to keep their stuff private. But if you have everyone in TDX, you have also relays. But okay, if you have the proposer inside the supply chain, you as a user, you would be able to send your order flow to this whole network without exposing your intents, basically. And so you will have a pre-trade privacy, and you would also have some neutrality guarantees provided by the TEE. And so, for example, Platypus are working in that direction, right? They have the builder that's working completely inside TDX. And if we put the proposer inside TDX as well, we could leave any other parties from this supply chain, and we have basically fully trusted supply chain that preserves the order flow privacy. Yeah, we could do that through, we could achieve better censorship resistance through proposer commitments, but also, yeah, put them inside the TE and just link their configuration to receive and process commitments from searchers and builders in a deterministic way. So basically, they wouldn't be able to, for example, to take better blocks from non-TE entities. Okay, so the full post on searching site TDX, if you didn't see that, it was posted some time ago by Angela, and you could get through this QR code and get the link and read the full article.